Hi, good afternoon, everyone. This is Shanti from Team Cognixia. I would like to welcome you all in this Vibe Coding AI webinar 2.0. We have our instructor, Mr. Sai Natarajan, with us. We will get started with this session very shortly. Thank you for your patience. Hi, Suraj. Very good afternoon. Good afternoon, everyone. We are waiting for more attendees to join in. We will get started with this session very shortly.
Deepa, it's only 5 minutes since we start session start. That should be.
Yes, sir. Yes, sir. I think now we are good to start the session. I think everybody is here. I would like to welcome all of you in this training program once again. We have our instructor, Dr. Sai Natarajan, with us. Over to you, sir. Please take the lead.
Sure. Thank you, Deep. Thank you everyone for joining the session. Glad to meet you all again. Uh, so we will straight away start with the session, considering today being just 1.5 hours of webinar. So we will straight away start. And this is going to be a vibe coding and agentic AI related session. And the session is 1.5 hours, so we will get started straight away. So I'm Sai Natarajan here. I have around 16 plus years of experience overall in IT and AI. I've worked on many projects related to AI, machine learning, predictions, text processing, uh, computer vision, etc. We have built few projects like AI-based image extraction, image generation, even image-to-image search. We have built multiple projects for multiple different clients. And related to training, I've been delivering training for the last 5, 6 years, and I think I've delivered around 200 plus AI batches, of which 100 plus are Gen AI. Okay, so I've also done a lot of application development in Java, Spring Boot, and microservices, and we have also built on other languages like Golang, etc., for performance. So this training program is going to be kind of like a initial uh, informative sessions where we will try to understand what are the capabilities of the AI in the current situation, what are the model capabilities, and what we can do with them, and what kind of agents can be built, and so on. So that is what is the main objective of the session today. Okay. So with that being said, we will straight away get into the technical aspects. So what we will be discussing today will be on generative AI architecture. We'll be discussing about like the AI models and their capabilities, and we'll also discuss a little bit about prompt engineering and AI-based software development, like agentic AI application development, and probably even delivery to some extent. Okay, so that's what we will discuss in our today's session, and I plan to include a lot of agentic AI related information in our session today. Okay, so as I said, we'll focus on AI first to agentic AI, agentic first type of paradigm that we are seeing here today. So we will discuss that, and then prompt engineering from application development, ideation, etc., and code generation, not just code generation, also test-driven development like generating test cases, etc. So some of the development tools like Copilot, Cursor, we will do a comparison. And multi-agent systems, I'm planning to show you a small application that I've developed and what it features. And also finally, we'll discuss about responsible AI, etc. Okay, so this is the plan, and we will get into the agentic first as a solution. Okay, so the agentic AI, what is the main benefit? Okay, so the purpose of the agents is to increase the speed at which we can deliver software, and it is not. We will see like how the agents are available in the tools like Copilot or Cursor, but at the same time, we will also see how agents can actually perform the task instead of just giving us guidance what to do. And I will also show you some of the examples that I have built, which are based on some of the requirements from different parts of the team. It's not like just the code development related tools, but I also have built agents for the HR team, agents for finance team, kind of like multiple different use cases we have planned. Okay, so I'll try to cover some of those. I may not get into the depth of the code, but I'll try to give you some high level overview of code walkthrough in those exercises as well. Okay, so that is what I would like to do. And what we used to do was like the traditional way of writing code and testing and the debugging. So they're all almost getting obsolete by now, right? So at least right now we are in the second stage where we are doing AI assistant programming. Right, so already we are seeing about more than 50% to 60% of the generated code that is written now is actually written by AI, right? So a lot of AI related code generation is happening. And next is, which means now we are mostly doing a prompt driven coding, code generation rather than us writing code from scratch, right? So, and we are pushing them into production. So then a lot of testing and other things are supposed to be integrated with it. So we will see the whole flow and the complete right from ideation to the deployment. Everything should be optimized or it can be automated using the agentic system. Right, so that is what we are going to see. So basically, the AI systems are going to think, ideate, develop code, and test it, and even deployment, monitoring. So everything will be done by AI systems right now, right? So, or at least we are moving in that direction overall. So what that means and how it really works, have some specific inputs. We will discuss that in the next part. But I think I'll try to show you an example of how agent-driven or AI-driven application development works. And probably I'll start with a small demo, and then we will proceed from there. Okay, so what I'll do is I'll actually create a new demo folder. And in that demo, we will actually probably write a small Python application and see if it really works. Okay, so we'll launch a command prompt, and then we will launch the VS Code there, probably VS Code, and probably I'll open that particular folder in the VS Code so that we'll set that as the project, and we'll start from there. Okay, so let me open the folder. Folder. Yeah. So we'll start a fresh project. So what is the agent mode is what we are going to see first. So as I said, we are not just going to talk about code generation, end-to-end deployment and testing also we can do. So we will see some aspects as we proceed one after the other. So let's see, we'll start with like write a Python like snake game and launch it. Okay, so before I ask it to do that, so before launching, check if Python is installed, and check for dependencies, or I would say install missing dependencies and launch the application. Right. So this is what we are saying. So basically, the point is we are not just asking it to write code. So which used to be the Gen AI world, right? So now we are in the agentic world where the AI models are given permission to like write code, even install softwares in our system if needed, and then proceed. So now you can see it was missing probably a Python environment in my system. So it asked me for the permission to install the dependency. And once I gave the permission, it is going ahead and proceeding with the installation. So this part is actually called as a human in the loop, right? So where the AI has to be given a lot of permissions to work autonomously, but at the same time, the autonomy should be possible to control by us, right? So the control is actually through the human in the loop. So which means whenever we design such agentic AI systems, we should probably have the or should give the user the privilege to stop an agent or AI from taking any particular decision if needed. Okay, usually we allow the AI to do the task which is going to be helping us, but if we found that if we find that it is not going to be helping or probably it is harmful, then we should be able to stop it from doing anything that is not desirable. Right, so that is what is the idea. And you can see first it has set up the environment, it has installed the dependencies. Now it is allowing me, asking me to show the code, and also now it is asking me to run the code. Right, so end to end, what did it do? So basically, right from installation of dependencies, creating the environment, and now you can see the game is ready. Right, so and it launched it and showed me the running application, and okay, so and I was able to run it. Right, so that is the idea. So I'll say launch the application again, and you can see like from 1 year ago, where the agent mode was introduced, it would have taken a lot more permissions, a lot more things to actually run this. But right now we are giving a lot more autonomy. So what is the point? So whatever we would have been able to do for sure, right? So as users, you can see it's actually giving me a working running code straight away, right? And then it is actually, okay, so I'll leave it. So the point is we are actually giving a working solution. So which means that it is not just going to help us to write code and debug and troubleshoot, but it is also going to help us in setting up the environment, whatever dependencies are missing. It can pretty much manage everything. So for example, when I was setting up the GitHub account, so for example, what I want to do was I have set it up this earlier. So where AI can look into my GitHub account, look at my repository from where the code is downloaded, see what are the PRs or issues reported in the GitHub account, GitHub basically reported as issues, and then it can download those issues and ask me what is the issue I want to resolve or list. And from those, I choose the issue I want the AI to fix, and it identified what is the issue, what is the file, went ahead into that code, fixed the issue, and then close the issue in GitHub. right? So end to end, we can have integration. This feature was introduced with a feature called as MCP integration. Okay, so now the VS Code will act as an MCP client, and the GitHub will act as an MCP server, and the client can request for information from the server, download the information, act on it, and then call the APIs to close the issue in the GitHub server. Right. So up to that end to end we can do. So that is the new way of development. So what did we do? So which means now when we are talking about agents, we are not just talking about writing code alone anymore. Right. So they can do end to end complete actions. So if it can set up the environment locally, it can help us set up the Docker images. It can help us to push this image into like Azure and deploy it into a Kubernetes service, everything it can do. So what actually is needed for an agent to work up to this level of autonomy? So we can see agents will need perception, so which means where it is, what is there in the system. So for example, first thing it realized was there is no Python environment. Then it created a virtual environment, and then probably identified what is the intent of the user. So the user wants an application to be written in Python and executed. Then accordingly, it chose to install the Python environment. And then the reasoning. So is the environment sufficient? Does it have anything missing? So in that reasoning, it identified, for example, the dependency that is Pygame was missing, and it actually installed it. And then the next action was to actually create the code file. And then the code file was finally executed. And then from that, it realized that the application is working fine. There is no error. So which means all of this happened in first time right solution, right? So for example, even around 6 months back, so AI would have taken a lot of stumbling blocks. So it would have faced an issue, it tries to take a corrective action, debugs the issue, fixes it. It takes probably half an hour to 1 hour to show what I did now, probably 1 year ago. Right. So that is what is the maturity of the AI systems. So they are now able to do a lot more planning, reasoning, action, and learning in first time right mode. Right. So that is the kind of capability we are seeing right now with the AI agents. So why do we need agentic mode? Because basically the AI could give me the installation instructions. It could tell me how to open like a PowerShell or command prompt, create the virtual environment. All of this it could allow. It could easily teach me, and I can do it. So that is probably the ask mode, or where just the Gen AI mode, right? So in Gen AI, you are given the solution, but you have to implement the solution. So what is the agent mode? So the agent mode is where it doesn't just give you the solution, it actually acts on it, performs the solution, and gives you the working environment. So that is what is the agentic AI. So there is a tremendous shift from Gen AI to agentic AI. So right now, all the companies are moving away from AI first to agentic first because of this reason. So right now we are in the agentic AI world, and agent first mode is what everyone is trying to get into. Okay, and many use cases are there. For example, logistics planning, we are deeply integrating AI into these solutions. What is the purpose? For example, we have seen a lot of disruption in the logistics in the recent times. For example, flights has to be diverted, avoiding that region, and ships cannot move, and so on. So now, if AI can look into the world, excuse me, like look into the weather, look into the news, identify any disruptions, and totally replan everything. So even choosing a different shipping vendor, shipping lane, it can steer or reroute completely everything to uh, avoid the problem that we are facing now. Okay, so that's the capability we have. Sorry. Okay, so that's about one of the capabilities that we have from the AI. So similarly, we have like physical bots, the robots that can completely take care of logistics in an e-commerce warehouse. So they can perceive. So in all of these cases, these are all nothing but agents, right? So and then they can monitor, they can detect problems, they can fix it. So all these can happen much more faster than human beings can do right now, right? So which means that the adoption of these systems is going to accelerate further and further. So at a tremendous pace. So what are the core components that we will need to build these kinds of systems? So we need the core, which is the brain, which is the LLM. And then there are different types of memory that you will need, right? So you need the short-term memory, so which is the conversation memory. And then we have the long-term memory where did this customer come to me earlier? What was the issue he has like faced? Is if facing the same issue again, that kind of a knowledge if I have to have that long-term memory. And you also have to have semantic retrieval. So for example, we use RAG. Mostly the long-term memory is associated with the RAG and we pull the data from a database. But again, the memory is evolving very rapidly. So apart from the short-term memory, which could be episodic, right? So what happened today versus what will happen tomorrow. So tomorrow will be another session. So that's the conversation memory. And we usually store those data in systems like Redis or local file systems, some logs, etc. And then apart from these two, there is one more very interesting thing that is happening right now, which is so the short-term memory, which is episodic, whereas long-term memory, which is probably the knowledge base and probably similar solutions, etc. And then there is also procedural memory that we are actually adding further. So the procedural memory or the procedures that are needed, how to actually work and fix a problem, we are going to have, we are going to see them through a process which is called as skills. Okay, so we'll see that in the next step. So then you can see there is tools. The tools that are needed, like for example, the AI agents can be integrated with tools like web search, internet search, access to GitHub, as I said, like they can automatically log into your like Jira or GitHub, look into the errors, identify who's assigned. If you're assigned, then it actually downloads that issue, fixes it on your behalf, asks you whether your confirmation is it okay, and if you're fine, you give yes. Then it pushes and then sets the status to resolved. So that is the level of tool integration that AI can help get, right? And then apart from that, yeah, you can see that the Python code execution environment it created and executed in a separate isolated environment. And we also have, as I said, enterprise connectors. Like we have connectors for Salesforce, we have connectors for even Gmail, Google Drive. Everything is now connected to AI now, and we will see probably one or two connectors at a later stage of time moments. And then we have multi-agent systems. So multi-agent systems have a lot of different advantages over a single agent. So I'll show you an example where we will, I may not run it, but it's almost like a demo. I'll show you a complete execution flow of a multi-agent system and how it really helps to solve a very complex problem and or at least helps in resolving and helping a human agent to solve a customer support ticket system. So that's the kind of use case I've taken. And the multi-agent system, I'll probably keep it like a short code walkthrough come demo kind of thing. And I have the code already in my collab environment. I'll actually take that and run it. So, or at least I will show you the walkthrough of the code. Okay, so give me a moment. I'm actually pulling that. Yeah. So this is the code or the implementation. Search for that particular implementation. Open that. And we'll see the demo. So the next demo, what I'm trying to show you is a multi-agent system. See, the use case I'll tell you, it's actually a customer support bot for a telecom company. So you have a company like Airtel or Vodafone, and a lot of customers have different problems. Some of them have internet issues, some of them would have traveled abroad, and then they would have got a bill that they did not expect. So there are a lot of issues. So what I've done is I've created a knowledge base, and this code is actually dynamically going to pull that knowledge base from the internet, and actually it is going to try to resolve the issue based on the information that is there in the knowledge base. But apart from that, I'm going to show you an example where we have built a completely agentic system. And we are going to have, see, ideally, this entire solution, what I can do is I have a customer query and have some past similar issues. I can combine them in a RAG pipeline, give the merged information to AI. AI gives the solution, and I can easily give that back to the user. It's very, very simple. One prediction, everything can be done. But what I've done is I've taken the overall situation to the next level, next higher level, and we have analyzed the information on many different aspects. And I'm going to show you how much it can be helpful or way ahead compared to just running one prediction once. So we'll see that. So we have this dependency installation step here, which I'm going to skip. And what I've done is, you can see I've done like around 6 or 7 different agents that are implemented. So one is a competitor agent, another is a strategic thinker agent, another is an evaluator agent, which will verify if the solution is correct. And then there is an adversary agent, which is actually going to attack the solution given by the previous agents. And then there is going to be a federated agent which is actually going to resolve everything and give a final solution. And you can see based on the complexity of the task, we have used different types of models as well. So some slightly older models, some very new model, but more complex decision-making capabilities. So we'll see how they work. So in this code walkthrough, one of the main things that I wanted to show you is that, so as we built into agentic systems, AI-based systems, and these are all built on LLMs, right? So language models. So then what is the point is that the core functional logic of an application is gradually shifting from hard-coded logic to prompt-driven logic. So which means right now, as we build more and more agents, you will see that around 25 to 30% or even 40% of your applications, which are AI-driven applications, are going to be natural language prompts. And even making a small change in the prompt can actually have a significant difference in the policy or decision-making ability of the agents. Okay, so for example, you can see I've given give a compensation up to 25%. So then if I just change this line from 25% to 0, you will see a dramatic shift in the approach that the AI takes to solve the problem. But what we have essentially done is just one line or even one word change. So the point is, applications are more and more being prompt driven rather than hard coded, right? So like typically with a normal application, all our intelligence, all our domain knowledge, everything is actually put into code, right? So gradually that is shifting and the domain knowledge is removed from hard coded logic and converted into prompts. So what is the benefit? So the main benefit of doing this is if your end domain users are aware what is the change they need, and some of the changes might just be a prompt change, then put a UI around this system prompts or policy prompts, allow the users to directly edit it, and that can have a significant speed up in our ability to react to new changes needed. Okay, so which means major application changes could just be a prompt change away. Okay, so we will continue. Thank you. So we'll continue. So this is actually built on a land graph code, but I'll give a high level overview of what we are doing. So in the competitor agent, we have said that we have a competitor A and we have a competitor B. So these two agents are going to provide the solution to the same customer question, but based on totally two different aspects. The competitor A is going to provide a cost-effective solution, which is most cost-effective to the company, right? So whereas the second agent is going to provide a highly empathetic customer satisfaction solution, right? So which means customer is more satisfied. So you can see already, so we are thinking on both aspects. And then next agent is going to be an evaluator agent, which is going to identify which among the two solutions from these two agents are actually more effective and will give. But what if we can have the best of both worlds? We want more cost-effective solution to the company as well as the best solution as per the customer satisfaction. Then instead of better solution, I can say, for example, select and merge the two solutions. That is possible. So which means then you can see like it will have a dramatic shift in the way the solution outcome will come, but it will just be a instruction level change. So this is what I was talking about. So prompt changes will have totally behavior level changes of the application. And then this is an adversarial agent. So this is one of the main feature that actually strengthens your overall solution. So what we are going to do is we are not going to directly accept the solution from the AI. So what if the customer is still unsatisfied and he's going to reject? So we are going to put the AI into the customer's shoe and say that you are an unhappy telecom customer. This is a solution generated by AI, which you are not happy about. Find weaknesses, missing compensation, and any other possible dissatisfaction and tell me all of that. So what we are doing is internally, one agent provided a solution, other agent is attacking the solution. So it acts like an adversary, thinks from the adversary's point of view, how it will look like, and then provides a feedback, right? So we take it as an adversarial feedback. Then what we are going to do is we are going to say, for example, this is a selected solution and this is the adversarial feedback and these are the telecom policies. Accordingly, refine the overall solution. Now what we are doing is whatever possible reasons why the customer might reject the solution, I'm taking that and merging with the overall original solution and giving a solution here, right? And according to all of this, we have given all of these and then asked the AI to finally give a complete comprehensive solution. And this is how it looks like. You can see the initial customer request goes through all these agents, finally gave a solution. So as I said, we can actually resolve this issue just with one agent. But what is the benefit of having these many agents? We will see. So for example, the question that the customer asked was, why was I charged international roaming despite disabling it? This was the question. And let's look at the AI generated solution. So you can see it says first, these are the policies. And so it says first, personally empathy, right? So it apologizes and says that we are really like sad, like, or we really apologize for the problem that you have faced. And I will look into the error, identify the problem, and you can see it gives a complete working procedure how this issue can be resolved, which can be used by a human agent. But if we really have the tools, integration with the telecom system, we can actually go and resolve the issue also. Okay. And if the policy is, let's say, as per its own decision, it decided to give 25% discount, then it can directly apply that. So which means a lot of human level things are automated by the agent. Okay. And it finally says that final solution also it gives. Resolution is refund credit 100% in currently charged amount and apply up to 25% for error because it's a mistake from our end, and provide a written summary. This was the issue and this is the corrective action. Okay, and so on. So it actually gave a working solution, but it also gave a lot of additional details what can be used by the customer. And you can see finally what is the customer facing agent, human agent should say. So it says start with an apology and then say that this roaming is actually charges pinpointed. I have found the error and it will be refunded, etc. It gives all that information. So, but the point is that we have thought through many different angles and come out with a solution. So, which means agentic is not just about resolving the solution with an agent, but enhancing it, looking at multiple different angles and completely provide an end-to-end solution. And it's not like just suggesting the solution, but actually with the integration of tools, we can go ahead and implement it. Okay, so that is actually what is the current generation AI models capable of. And I don't have the telecom CRM. Otherwise, I would have showed you even integration where it resolved, applied the refund. So everything we can simulate. Okay, so or actually implement. So that's the capability that the agent models have. So I think we have went through the first half an hour. In the meantime, if you have any questions, whatever we have discussed so far, I would like to address them. So do you have any questions, whatever demos we have seen? Yeah, clear hand raise. Please go ahead. Will you be able to unmute yourself? Yeah, I'm allowing mic. Or you can actually use the chat. That's actually more better.
Oh, yeah, no, no. I mean, I just want to understand, like, you created this all by prompt, vibe coding, or
Yeah, so it was like I had a reference code on LangGraph, but otherwise the entire code was generated by AI.
okay. So, is it possible? Can you show us some sample, like how the vibe code you have done? I mean, like you are giving the solution, like how it was, how it is working. But I
Correct.
just interested in like your vibe coding
Okay.
concept.
So basically what I did was, like I took a LangGraph sample code, which I had pretty old. Okay. So to give an example, I didn't plan to show this, but since the question is there, I'll try to show you that. So if I go to one of my uh, old versions, right? So I had a very old version of this LangGraph coder, and it was actually having a lot of issues because the recent changes, upgrades actually made my code to fail. Okay, it didn't work anymore. Then I had to do a lot of upgrade. So this is my original code. So this is the code. Okay, so it's actually a code generator. Given a requirement, it is going to write a Spring Boot application and it's going to save the file locally. So this is the original LangGraph code solution I had. So it had a code generator node. It had for example, a code compilation test node. This is the code generator, which is the generate. Okay, and then this is the validator that actually checks the code for compilation issues, etc. And it has a reflection node. If there is an error, what are possible ways to fix it? It actually gives a grounding. And once we know this is the possible way to fix it, then the feedback is given to the reflection feedback is given to the generator. The code generator again sees the previous version of the code, the fixed issue, error, and the possible fix. And then it generates a new version of the code. And it runs in a loop until the code completes. It builds a completely working code until the test passes or max iteration is reached. So this is the original code. And this code, first I took like around half an hour. I used a VS Code with a GitHub Copilot to upgrade it. So the upgrade took like around half an hour for finishing. Okay, so I can actually even put that code here and show you, like I can ask it to upgrade and test it and verify it. So then what happens is it took like around 20 minutes to 30 minutes for the fix to happen. And then I had a working fixed solution. Then I took that solution and then asked it to implement the new feature. So notice that I've done two steps. One is to first find any issues with the current solution and fix them. Because if you have a clean solution, then you give that clean solution to the AI, then it doesn't have to do any validation. It can just use the reference code and generate completely new implementation, assuming that everything will work, and actually it should work. Instead, you ask it to first directly generate the working code in the new features. Then what happens is it has two unknowns. One is the migration issue, upgrade issue where the code is not working. The other is there could be some bugs and implementation issues with the new features as well. Then everything will actually collapse and things will really go bad. So what I actually prefer is if you have a solution that is got from somewhere but not working, then the first thing you have to do is probably upgrade it. Okay, so I'll probably come back here and you can see this is the code. I'll say this is an old version of my LangGraph implementation, right? And upgrade to latest version, right? So this is what I'm saying. So now what happens is, unfortunately, I don't have the OpenAI API key to actually test it, but it should automatically try to fix it. Okay, so once it takes some time, identifies compilation issues, fix it. Maybe it may not run it, but at least it will do the compilation, identify compilation issues, try to fix it. Right, and you can see it straight away says that these are the changes needed, and it is trying to probably implement it. I can ask it to even do a test run, dry run, check if it is working, and then ask it to fix. Right. So once we have a working solution, I'm actually not checking it because I'm speaking simultaneously, but you should ideally check all those changes and then see. Okay, so do a fast check of the code for compilation errors and fix them, right? So we can first do that. And once the compilation checks are done, there is no error, everything is fine. Then what we can do is we can actually go ahead and use this as a reference code and then give the new use case that you want and then make it work. Okay, so that is the idea. So following the same procedure, uh, I did another exercise that's for a different purpose. So what we had was like around a large project with the agent to agent, a lot of different agents we had. So as I said, we had initial issues with the working mechanism. Like it took around 45 minutes to 1 hour for me to fix them. Once I had the working solution, I gave the complete requirement of the complete end-to-end feature and asked Cursor to implement it. So when Cursor did that, probably it wrote around 70 files, okay, probably enormous number of lines of code in less than 2 minutes. Okay, so that was an eye opener for me, even because I used
Hi,
to.
sir.
Yes.
Hi, sir. I think there is a question in the chat box from Rahul Tanwar. Can you please
Okay, I'll
check?
address that. Sure, sure. Okay, so that is one point. So basically, where the speed at which AI was able to generate so much code and all of that working code. So in fact, I was amazed when I ran it immediately after seeing so much code being generated. I was really feeling that there could be some issues and errors, and I may have to go through debugging, etc. So when I ran it, everything worked perfectly first time. So that is the capability that I was experiencing with Cursor. So at least Copilot can do, but it's not as fast as Cursor, right? So that was the experience I had with Cursor. So now there is one more question. How do you ensure security of the output generated by agents, like no authorization information should be included in the output, etc. So that should be part of the system prompt that you give, right? So basically, AI can do everything or anything that you want. Then what you want is something that you have to ask. So which means to some extent, AI has its on its own knowledge. What are the things to do and not to do? But to really ensure that enterprise grade workflows and security that you get, you have to drive it. Okay, so then like these are the policies I showed you, right? Even the telecom fixing, I showed you the policy. Then similar to that, so you have to create like a readme.md or something, which actually is like an instruction to the AI itself. So these are the things you have to do. This is the flow in which you have to do everything. I'll even show you. So how to build such a flow, how to implement such a solution, I'll try to show you. So you can build skills that actually defines this, the always whenever you generate code, this is the skill with which you have to do. So you can do something like that. And that actually takes that skill and actually performs that. I'll show you with an example later. But the point is, yeah, so you have to ensure you have to have all that information in the instructions. Fine. Or at least we have to get those instructions imported from someone else who would have created such a skill, because these are all now everything is open. A lot of people are actually giving those skills for free. So then import those skills and use it. That's another way of looking at it. Fine. So now we have seen one demo. So I'll show you that. So for example, since the question related to skills came, I'll try to show you an example of how that skill looked like. Okay, one moment. Okay, so we'll see that. So what I've done is related to agentic AI, I've implemented some or got some pre-created implementation examples. I'll try to show you that. So just trying to get it. Yeah. So these are all examples of agentic AI systems. Again, this implemented with the same code base as I showed you earlier. So what I did was almost all these files, use cases are different. You can see one is a legal contract reviewer, another is a finance month-end closure analyzer, another is a HR onboarding agent, etc. So these are all different agents. In an IT incident triage agent, it can identify if someone reports an issue, identify what is the problem, maybe some software is causing an issue. It can even uninstall that software. So all of that I have built here. Okay, so that is the IT incident triage agent. All these agents are implemented in LangGraph. So why LangGraph is because like there is a methodology, there is a flow. So I can say this is the first step, this is the next step, and so on. Right. So if I go back to this use case, right? So you can see this is the flow. So for example, first do the review, then do the analysis, then you do the execution and so on. So you have some specific flow. So all enterprise actions are workflows, right? So then you can build exact workflows using LangGraph. That's the main idea. Okay. So here, if you see, we have given some risks. I think this also has some extent on your security requirement, right? So you can see, I can say these are all the problems I'm facing, or you should consider, and accordingly ensure that the security implementation you provide should actually ensure all of these gaps are fixed, right? So you provide those details. Then what happens is AI becomes much better. That's the idea. Okay, so this is the code, and you can see again, major part of the overall solution. The text, the prompt that we give is the core part of all of this. Okay, so now I will show you what kind of analysis it did and what is the output it generated. So this legal contract generator, I'm not getting into the code, but I'll show you the high level overview of what it does. So this is the contract summary that it looks at. So it's going to look at, so for example, there is a new, let's say, quotation that you have to submit to a company on behalf of a company for a new project. Okay, so the project contract requirement comes like this. Okay, so you can see what is the document, who is the company, what is the requirement related to, what is the value of the project, what is the duration of the project, etc. So you get a lot of terms and conditions. You can see there are some terms and clauses that are given. So termination clause, liabilities, data privacy, and so on. So which are normally expected from these kinds of projects, right? So this is the project contract information you have. So what we have done is, imagine you have a 200, 300 page document. And for every, and you have to go through like 2, 3 documents every day to submit 2, 3 codes per day. So you're in sales or pre-sales. So this is what you are facing. So can we use AI to actually look into it? So what it's going to do is the AI code that I showed you now, which is here, the line graph implementation. It's going to ask the AI to look into the code, like the data, analyze everything, and then classify the results into multiple categories. Like, so you can see everything is fine, clean. There's a high risk project, avoid. Probably there's a mixed, maybe with some decision making, you might still want to go ahead. So this is a kind of analysis reports it's going to give. And whatever the input I showed you, it's actually it classified it as a high risk. So you can see this particular contract ID, risk level is critical, and it had 5 issues were identified from this document. Okay, and it says it's an escalation and it's escalated to the human. So for example, you get an automated list of document analysis, all the incoming new requests are analyzed, and some of them are auto approved, some of them come to you for analysis and approval. Right. So, and when it comes, you don't have to again read the whole document. You should ideally, but it gives you focus where you can focus. So you can say it says that these are the 5 high risk problems that is identified, and you can see the first one is it says matched risk pattern is may not terminate on convenience. So which means as a company you cannot terminate for certain reasons. That could be a problem, right? So if and then another risk pattern is gross negligence, and there are some issues. Probably you have some penalties to pay, etc. So you can see these are all high risk terms that are there, and and it says this is the exact place where this problem is. You go and read it and take corrective action. And you can see it says what is critical, what is high, and what is medium also. So which means it actually categorically organized or reorganized the places so that out of the 200-page document, these are the 10 pages that you have to really focus on. So with this level of focus or refocus that AI gives, you can like do amazingly fast response. But the point is, you can see that the whole analysis and summary is done using code. And it's an exact workflow of exactly how this analysis should be done. So what I've done is, but almost all of this is actually text processing, right? So input is text, output is also text, and I have a fixed flow. And now why do I need code to do this analysis? So with agentic systems, can we completely uh, achieve the same results, but without writing code? So that's what I wanted to do. So then what I did was I use Claude Cowork very much now. Even some of the TOC changes I've done using AI. And what I've done is, if you see, so I gave that code. Okay, so and also I asked it using this code and the data that I have given, identify the exact business logic methodology that is used. You can see all these text files I've given, and I asked it can you look into the code and the sample data, the input and a corresponding output, and identify what is the business logic used, and give me this output as a Claude skill. Okay, that is what I did. So now what is essentially happening is the processing logic of this use case is mostly a workflow that says first you analyze this, next you analyze this, next you analyze this, and finally give out a report. And also give a decision, escalate or everything is fine, etc. So that's the flow. Then what I did was I asked it to generate a skill. So then what happens is it gave me a working skill, which is here. Okay, so you can see this, it is a zip file. Okay, so the Claude skill is actually a zip file, and I'll show you what is there in that zip file. I've already pre-created it and downloaded it, so that I can directly show you the demo of it. Okay, so this is the skill, and a skill will be nothing but, if you see, it has only 2 major things. Okay, so okay, a readme.md file, a skill.md file, some scripts, and some references. Okay, so if you look at this skill, and what are these file components? So why do we need that, or how AI will use that? We'll see that. Okay, so if I look at it, so we are now gradually getting into skill-based agents. So which means many of the use cases that we are going to get, we may not even have to write code to achieve them. So all of them, you will get a common client like Claude. I think even when I went into a company named Amdocs, and we were trying to talk about agentic systems, how to build, etc. So many of them were actually using Cursor, the agentic system, for a different purpose apart from programming. So which means once these agents are so powerful and they can be integrated with MCP-based tools, etc., they are not limited to programming. So they can actually deeply integrate it with your enterprise and do many things that may be automatically taken care with this kind of skills-based analysis. And you may not even have to build a new application for it. So that's what I wanted to show. You can see what I've done was, so what these skills will have. So the skill is mostly a procedural knowledge. As I said earlier, in the memory, short-term memory, long-term memory, and also you need procedural memory. So which means what to do, how to do, right? So that is the information that will be there in the procedure. And internally, they have a feature which is called as progressive disclosure. So what is progressive disclosure is nothing but in a client like this, which is multi-purpose, can be used for anything and everything in your work. So you might have hundreds of skills loaded. So if I go to the skills, you can see that I have loaded already many skills. Okay, so one for some, you can see one is for productivity, one is for project management, another is for sales and etc. So you can see there are a lot of skills that are there. So then what happens is you have too many skills, and the user might request, or for you to fulfill a user goal, any skill might be needed at any time. Then what you do is you don't load all the skills, but you have to know what are the skills you have. Then what it does is it actually just loads the name of the skill. So in this case, the skill I've created is in the zip file that is present, right? So this skill is actually for legal contract analysis. The name of the skill and a very short description, what this particular skill will give or enable you to do. So that's the information there. And regarding every skill that is here, right? So sales, operations, etc. From all those use cases, some skills will be loaded in memory. It will be there in the cloud memory always, which means in your LLM. But when the user specifically says uploads a legal document, and then you look at the document, you can see that it's a legal document. Then what you do is you load the rest of the information. The rest of the information, the skill.md will have instructions, exactly the procedure, how to analyze that document. And then during the analysis, you may want to do some automation, you want to have some tools, etc. So then those tools are nothing but scripts, Python scripts also, and those will be loaded into this scripts folder, which is here. Okay, and then there can also be reference documents, which is nothing but the reference documents are the sample use cases that we were talking about, right? So even the low risk, high risk, etc. So some examples of each. So all of this is now inbuilt within that skill. So what is the benefit? Now this probably this 200 lines of code, whatever actually 400 lines of code. So whatever this workflow did with an enterprise application, entirely once you like tell this is the procedure and build a skill for it, you can eliminate that code and you can just use any client and it can actually implement it. Can run it. And what I've done is I've just prior to the session ran it. I'll try to see if I can show you. So, and for the skills to work, you don't even, once you build the skill, you don't need even an enterprise account. Okay, so even a normal account will give you. So what I've done is you can see, use the skill / and then the skill name, which is the legal contract analyzer. And I uploaded a text document. Okay, so this is a document. And then I asked it to analyze. And then you can see it produces an exact, very similar response like what the original LangGraph coder did. And this time, what is the benefit? I'm not executing any Python code, so I don't need any Python environment. It need not be hosted anywhere. And also more importantly, you can use any LLM. So for example, if you're using a hosted environment, you need an API key to access the LLM through a Python code. But now you don't even need a API key, right? So this is going to be a huge disruptor. So many of the use cases we are going to see, they may not require you to write code. So you will only write skills or create skills and then upload them and integrate with your overall application. Okay, so that's something. And even if you are building agentic systems, you have to support these kinds of skills to allow your end user to dynamically choose whatever skill they want and to run a broader enterprise application. So that's about some introduction to these things. So now you can see like this is what I was talking about. So the memory, etc. So all these we have actually seen the core components of it, how it really works. Okay, fine. So now what is the next step? So basically AI can generate code, microservices, etc. So it can do like testing of these applications, etc. So we'll see that also in a short while and so on. So yeah, so we are finishing the agentic part of the AI solutions building exercise. Any questions up to the stage? Okay, I'll move on. Okay, so now you can see it is not just about code generation for which you need prompt engineering. So in the future, whatever code you generate will be agentic systems. And within your application itself, the prompts are going to be deeply integrated. So in that case, your ability to write code is not just going to have impact of once for generating the code. The prompt engineering skills you have will have a um, deep integration with application, and hence very deep or very extensive impact on the final solution you build as well, because the application itself will be made of prompts, a lot of prompts actually. Okay, so vibe coding is just not just about describing what you want, but also the quality of the code, the production level prompts, how do we write it, and what kind of test cases for which it can work, and what kind of performance capability it should have. All of this can be controlled through the prompts we write. Okay, so what is vibe coding at a high level, which we will discuss here? So is describing what you want in natural language and iterating through multiple times through the solution to improve it in a self-correcting logic, and then finally get a completely working solution. So it should be intent driven. So from the beginning, you should know what you're doing. To give an example, it's not just about vibe coding, like even enterprise grade applications are being developed through agents and AI right now. So to give like the current startup environment, what they expect, I'll tell you. So I think right now with tools like GitHub Copilot or Cursor that is given to you, so you will expect like people will become 2-3 times more productive, 5 times more productive. But in the startup world, like if you look at Silicon Valley, etc., so they're talking about 100x to 1000x productivity increase. So which means one single developer is expected to generate code or perform task in software development, which will be equivalent of 100 or 1000 people. So completely bootstrapped with AI. So that is the kind of productivity expectations we have. But I think with the tools like Cursor, I would say we are almost there. So even 50 to 100 times, I would say is not going to be very surprising for me. Right. So then what do you need? So you need a person who's sitting in front of the AI, who is given with a very powerful tool. So he should already have a deep knowledge about how to write code, what is the programming standards, domain knowledge, all of that should be there. So which means you just put a fresher, then you get only 2x or 3x, right? So, but if you put the right people in front of the AI, so we are talking about 50 times more productivity or even 100 times more productivity, right? So that is the expectation. So which means the prompts, the quality, the style, everything should be to that level, and the quality. So which means, and you might have to build this kind of tools, the skills that I was talking about, right? So because you know that if you have a particular domain, right? So then this is the exact flow to implement each and every use case for that particular domain. So then it might have some regulatory requirements. So that is where, and even the security requirement you asked, right? So it can be added as a skill, and you can, in the skill, you mention what is the exact need that you want the AI to look into. Then what happens is it becomes productive. So then I can say every time I have, let's say I'm writing a Spring Boot application, I write a skill saying that this is the way to write a MVC application. First, you have to start with entity. Entity should have constructors as well as getters and setters. And then you have repository, and then you have service class. The repository should have custom queries, and then you have controller, and all these are interrelated to each other. So you can see that there is a lot of information there. Then what you can do is provide some samples, put some very well written code, because what happens is you ask the AI to just write a code, it will not have exception handling, it will not have anything that is production ready, right? So it will not have best practices, validations, none of that it will have. In fact, in my previous session, I showed you a prompt difference, how it was. I can actually try to show you that same prompt again, right? So what I did was, you can see, for example, write a Spring Boot application to store employee data with ID, name, etc., and then implement entity repository control. So this is typically what we do. So in vibe coding, there's all that much we have to do. And you will get a working solution that will work. You can run the API, it will work, but nothing will work, and you will never put it into production. Then what is something that is production ready? So how do you write different prompts? This is an example of a prompt that I showed earlier, right? So you can see you are a senior Spring Boot developer act with extreme importance to quality, write a Spring Boot application to store employee data, and implement. And notice that what are the things, important things? I'll set the high level context. So this is something very important. So senior Spring Boot developer. So this is called as a role setting. Role setting is nothing but as what the AI should think itself while writing the code. Is it a developer? Is it a tester? Is it a senior developer? That actually has a significant impact in the output. And we are saying also give extreme importance to quality. That again adds a significant value to the way it produces the output. And then I have to now enhance this further, right? So now I said how it should work, but what it really should do, I can give further details here. So you can see validate inputs and outputs, okay? Add best practices, do naming convention carefully, handle exceptions very importantly, So these are some of the things that I've asked. So which means in addition to saying that it has to act as a senior developer, what a senior developer should do or should take care, that also I've put here. So then this code will have a significant impact in the quality of the output it generates. And I think I've actually showed this difference in my previous session. So you can see this first prompt here, right? So I started from a blank folder and created the Spring Basic folder. It created a pom.xml so that I had the dependencies of Spring Boot application. But we'll more look into the code, and it actually gave a working code. But let's look at the code. Okay, so maybe the entity, not the entity, maybe straight away to the repository. You can see that it just gave a blank repository, no custom queries, right? And then you go to the controller. There may not be any exception handling at all, and there's no validation at all, right? So there is no null checks. What if the employee is not found? None of that code will be there. It's a very, very bare minimal code. Even in the entity, if I go back here, okay, so there's the entity code, and you can see it had some details, at least a nullable is false, max and min as given. So there is some details here. Okay, so but let's see what is the output of this particular prompt that I've given. Okay, so I could do this again. I can rerun it, but it'll actually take more time, which we can save and have those time for other discussions. So let's look at the code that it generated with the second prompt. We'll start with the entity. Okay, so you can see this had some changes, like uh, it has put the entity here, the table name, column names, unique constraints are added, but it actually removed some validations here. I would probably have to change the prompt a little bit more maybe. But you can see that it actually added at least this much here in terms of quality. Next, if you look at it, let's go to the repository, and then you can see it added some custom queries. Okay, so then if you look at the controller, right? So it added some validations also. So you can see there are some patch requests that it actually allowed. It did a not null validation on the inputs and did few more things. In fact, when I checked the exception, you can see there's a global exception handler that was added, and there's a lot of exception types that were handled here. So these were all because of just two things: role setting, what it actually has to act into, and how the quality can be ensured. So similarly, if you are very interested in security, you are part of the security team, add everything that is supposed to be handled from the security point of view. Then it will automatically do that. Okay, so which means security is more, see, AI has the knowledge of handling everything. Then we just have to ask. We should have the knowledge of what to ask. That is the idea. Okay, so now there are two things that we have discussed. We can have skills that can actually implement procedures, and we can also have prompts that actually enforces the AI to act in a specific method. Okay, so next we will proceed further. Okay, so what vibe coding is not, like, just we cannot copy paste things, and we should not trust AI fully. It's always we have to take care of looking into the code, validating things, see if they are okay before running yes or allow it to save the code. We have to definitely check. Okay, and it doesn't mean that you just ask and you will get everything. So you've already seen, right? So just a few changes in the prompt can have a significant impact in the quality of the output. Then in that case, the quality of the prompt will determine the quality of the code generated by the AI. So in that case, we have to be very careful in prompt. So what we typically do is we write a set of prompts. Those are actually created as a prompt templates, and those prompt templates we will actually saving them. Maybe the more you create such prompt templates and then put it. So like for example here, except for this part, right? So most other things will remain the same. So in that case, create a template that will just put this as a placeholder, and then creates many prompts like that, and then share it among the friends within the company, and also download such prompt templates that have some best practices implemented. You will save a lot of time. Okay, so that's typically how the coding should be done. Then there are some prompt templates that are available, and you can see one of the prompting templates I've used is called as chain of thought, so which is reasoning step by step. Okay, so basically restate the requirements clearly and ask it to run edge cases and describe the algorithm or approach, what it has to do, and then analyze the time space complexity, write implementation. Like these are all different steps that you follow, and then eventually write the test case. And what I've done is prior to the session, I've prepared some like prompting techniques that should be used for such coding requirements. Okay, so I think I should have those prompts samples here. Okay, so what are the prompting techniques that we should use? I've given. So reasoning and action prompt. So certain use cases are there, particularly if you're building agents, then this reasoning action prompt is supposed to be used. And plan and execute. So how it should like plan to execute and reflect. So this is about like, for example, there is an error and the model is failing to generate an output. And while debugging, it's taking time. So then you can actually ask it to use this prompt that actually helps it to like reflect before regenerating the code. So we can actually put that as a prompt and that will actually make the code, the AI converge to a working solution faster. Okay, and then there is also a language tree, which is a tree based prompt. So what I've done is I've actually in my previous session, I've used a different prompt that I actually did not use today yet, but I can actually show that to you. So there is a like code generator prompt that I typically use as a set of prompting techniques. So the purpose of that is to use the AI to generate code. Okay, then in that case, what are the best practices I should follow? I have given some details here. So use prompt chaining. So which means don't try to solve the whole requirement in one go. Okay. So first break down the overall problem into multiple steps and then give the first set the expectation. And then once expectation is set, then ask what is the first to implement and then continue from there next. So that is a prompt chaining that is always recommended to be used, and use agents as much as possible and add skills that actually makes it really faster to work. Okay, and then there are different types of prompting techniques that we can use. So instructions on what the model should do, but more importantly, a lot of times what happens is don't give only instructions alone. To give an example, I can say ensure to write best quality code, ensure to do exception handling. I can give like 100 such instructions. If you give a lot of instructions, what happens is the model follows around 10 and forgets another 10. So which means giving too many instructions, the model does not follow all the instructions always. Then what is the best solution? Go for this one shot or few shot. Even in the skills we have seen, right? So give one well implemented sample as a reference and then ask it to write similar code for a new use case. Then it performs amazingly well. Major part of the overall requirements, including security, including any other aspects of app development, mostly it will be able to adhere to. So which means using references for code, which is a one shot or few shot, is much better than giving a lot of instructions. And then this role plays, which means exactly. So what is the role setting is very important in order to get the right output that we want. Okay. So chain of thought prompting is what I showed you like in the previous presentation, but I also have a more detailed example in a Word document I'll try to show you. So tree of thought is another. So the chain of thought is where you solve the problem stage by stage, and the previous stage output will be the input to the next stage, and then you gradually add more complexity. So that's typically how we should write code. So which means what is necessary is a base for the whole project. You should implement them first. So in that case, you can also use AI to actually identify what should be implemented first. I'm going to use chain of thought and ensure that the base should be implemented first, and then use that as reference to implement the rest of the things. Okay, so that's typically how we write. And then tree of thought is like branching. So where you go to one module, complete it fully, come back to the base, and then next module and next module and so on. So that is another. So tree of thought is another complex prompting technique that we use. Fine. So I think some of these slides I've covered a little bit earlier. So that what I'll do is I'll focus particularly on certain important prompting techniques alone that are important. So I'll try to show like 2-3 prompts where what I want to explain is that these prompting techniques will show you even for vibe coding as well as for writing a full-fledged application, what are prompts that are not well structured, which are open-ended, compared to what are prompts that are to the point, focused on executing a particular task. And everywhere you will see the knowledge and capability of the person who writes it, you will be able to show that specialization. To give an example, I can say, give me the code to find bugs in a shopping cart. So instead, we can say you are an act as a QA engineer and give me ways to debug an application, and then probably 5 edge cases which are going to uncover problems in the code, right? So the point is, you can see that generate 10 test cases data, and some are valid usernames password, in some are invalid username and password. So you can see that each of these correct prompts have a specific pattern. So the point is, you have to ensure the prompt you use will express the domain knowledge you have in doing that particular task. So which means there will be a huge difference in performance and capability between a code written using vibe coding by a person who is fresher, compared to a senior person. What kind of prompts should we write? So there's an examples of here. So all the correct prompts, if you see, will be expressing the knowledge and capability of a senior programmer, right? So as a registered user for a social media application, I want to be able to edit my profile picture. I'm already logged in, I'm in my profile page, and this is the functionality I want you to test, right? So that is much better than just tell me the user story for testing the application, right? So what you can see is in every use case, the correct prompt will have to some extent the role of the user, what is the page or module in which you're working on, and what is the exact steps, the procedure which I was talking about. You can actually embed them as skills also right now in the current versions of the AI. And then once you build that capability as a procedure, either through prompt or through skill, now what you can do is you can actually use the same repeatedly for every test case that you want to generate. So that's the idea. So now what I've done is I've actually taken some of those prompting techniques and I've put that here. So for example, one of the ways to ensure that you write the correct prompt. So you have seen some, I've given some examples of what is the incorrect prompt, which is very shallow, to what is the correct prompt. So are there certain guidelines that help me always to write a better prompt? So these are some examples that I've given. So you can see action, purpose, except expectation is one prompting technique. So what it does is you have to specify what is that and I've given some example also. You can see generate test data for a regular user attempting to log in. So that's action. And the purpose is to assess the login forms functionality and security testing. Even security aspect also we can test it as well. And then the test data should include both valid and invalid inputs, correct and incorrect usernames, blank values, maybe special characters, and so on. Right. So and then try to test it. So this you can see. So this is going to help you to get a much better test code, test writing, testing code, compared to just saying that I want to test a login page. Right. So that is the idea. So there are a lot of specific techniques, prompting templates that are available, specifically on code generation and test code generation. So some of them are given here. So the next is role, action, context, and expectation. So here the role, apart from the role and the context, sorry, action, also I'm providing context. Like am I logged in user? Am I invalid user? Like not logged in? And what is expectation? If you are a logged in user, then this is the page I should go into. And if this is the invalid user, then I want to get into another page. So, and these are the exception errors I should see. So all of this you put it. Okay. So this is another example of a prompt template that can be helpful to write a code. Next, I have context, objective, action, scenario, and test. So the point is, in this use case, the user could take multiple actions in a single page, and for each action, the scenario could be different. To give an example, the user is, let's say, current account, then the scenario is different. The user has a savings account in a bank, that's a different scenario, and so on. So in that case, or user having balance sufficient to do the transaction and insufficient balance. So these are all different scenarios for which I want to test the same application. Then we use this post template. And very simple task action goal. So if the user makes this task, then this is the goal I should be able to achieve and give me test code for it. Okay. So these are all different prompting techniques that are available. And I will share these probably templates a little later, maybe through some OneDrive link or so. But this is another use case where I wanted to discuss about the prompting techniques that are available for vibe coding. Okay, so which means it's not like you just ask what you want and you will get it. So there are a lot of specific prompting techniques that are available. And each of those techniques, when used in the right appropriate use cases, you will get significantly better output quality code compared to not using them. Okay, so and I've given an example of one such role setting and prompt anatomy I've given here. So you can see act as a senior software developer. We have a fast API application to be written. So the programming language, the framework, etc., everything you have to give, and the task, like what is the exact application functionality it has to use, and then the constraints, version numbers, compatibility issues, and the output, what it is supposed to generate. Okay, and then you can see this will generate a much better code compared to just asking, like, look into this code and then write a test case. Right, so that is the idea. And whatever the common use cases I've talked about, action, purpose, execution, expectation, etc. So all these prompting techniques, I've mentioned them here. So probably you can note them down, and probably when we actually go through the full-fledged course, we will see more use cases for it. So mostly now we know that the code can be generated and it works. What is the next problem? So hallucination is the biggest problem that you will face, particularly with code generation. If it really happens, it really breaks down a lot of things. So that is the next major problem that you will face. Okay, so I'll give an example of how this can happen. So for example, if I go to even ChatGPT, probably, okay, and then ask it to write some code. Okay, so write HTML page for Cognixia, okay, for expressing our, let's say, corporate training capabilities. Okay, so this is what I'm going to ask it to do. And definitely the AI will be capable of generating the code for me. And you can see it straight away starts writing some code. And it is actually going to give me a working solution, I'm almost sure. Okay, so this HTML page, when I run it, almost I'm sure that this code should work and I should be able to get a working solution. So I'll just wait for it to complete the code. I think it did. So now what I'm going to do is I'm going to copy this. I'm going to put this code here, okay, in a new file. Okay, I'll save this as, for example, okay, so com.html, okay, and then change this to alt type, save it. I think there is some issue here. I'll just remove that, and this also I'll remove. I think everything is fine. So now what I'll do is I'll actually run this, and let's see, it has given a very beautiful code. Awesome. So far everything looks fine. So what I'm going to do is I'm going to say one small task where it can actually hallucinate. Okay, so add our logo to the page. Okay, so this, what happens is now it will try to search for the Cognitia logo from the internet, and it will try to add. So particularly since it is Cognitia, it may not have been able to do, but you can see it actually already found a source, and this is actually the logo that I was looking for. Okay, and you can see that it actually identified the logo from this particular page, which is from our own website, and then it actually added. So this is fine. So what happened was they automatically have reduced the hallucination a little bit. But the lot of times what happens is this it will not do on its own. Then what happens is you will see it will generate some auto-generated path which may not even exist in the internet. Okay, so then that is actually called as hallucination. So the hallucination is where the model tries to make up things, even it might make up URLs that may not exist. Okay, so give me the URL to Cognitia logo, okay, and add to the HTML page. Okay, so and regenerate the whole page. Okay, so whole page. So this is what I'm giving. So I wanted to regenerate the whole website by adding the logo to the application. So let's see if it is really able to find the image, and if it has found it, then this code will work. Otherwise, it might fail. And you can see page can't be found. This is what I was talking about as hallucination. So what it did was it thought that our application is developed using WordPress. And if the application is in WordPress, then this is the URL. So it will be WordPress content, uploads, logo. So what it identified is it went through thousands of websites and they seen that common pattern. So what is the common pattern? WP content folder, uploads folder, and then the company name -logo.png. So this is the expected format in which it was expecting the logo to be present, and it actually auto-generated the URL, which is totally fictitious. So this is the problem. Okay, so and definitely whatever code it gave, I'm not going to run it because you know that it gave an invalid URL. So this is the problem. So how do we fix it? Okay, I'm going to fix it by asking one thing. Okay, so the logo did not load. Okay, so give me the reference to the page where you found the logo. Ensure to validate the URL from actual web page, and then add to the HTML. Okay, so now what I'm saying is I'm asking it to verify, provide me reference URL from where it identified the logo, and then I'm asking it to include it into the application. So a lot of times what happens is when you ask for references, it actually is able to identify the correct link. So for example, if I actually open this and then copy the reference link, then it'll actually have the actual valid URL. So this is one of the ways. So if applications hallucinate, what happens is they try to make up things that does not exist, like the URL that I showed you here. Okay, so this URL definitely not exist, and that is the reason our page not found is appearing. So the one of the ways to fix the hallucination is to ask for references. So what are the other ways to actually avoid or reduce the hallucination? I have some more details here. We have to give grounding prompting. So the grounding is probably first, these are the ways to analyze it. Give me the exact steps how you will analyze, then you would do it. So that is one of the way to ground it. Next is ask for sources. In my knowledge, reducing hallucination, one of the biggest, most efficient way to do it is ask for references. The moment you give references and ask the AI to verify the data before it gives, automatically the hallucination significantly drops. So this is from the AI point of view. And what is the other thing that we can do? We can add RAG, where the grounded information can be extracted from your own knowledge base, and human in the loop, where manual validation can also be done. But I would say something that is common that almost always I use is ensure asking for reference and ask it to self-validate. It's called a self-correction. So where it automatically verifies before it gives. So that way, if you ask for reference URLs, and then from that reference, it has to generate an output that actually almost always works. One of the ways to fix that is that. Okay. So next is bug fixing. Again, we can identify what are the issues and we can use AI to fix it. I'm not actually having the detailed information about GitHub Copilot debugging features, but I'm not actually planning to demo that. But what you can do is in the case of GitHub Copilot, you can ask AI to help you to do the debugging. So for example, compilation errors are easiest to fix, but imagine there is a deadlock. That's where it is much difficult to fix, right? So, but still, when you run it in the IDE, so they could see the code is hung in debug mode, and it can identify what is the exact line of code where it is found to be a problem. And then it also give you the description, and then you can actually ask the AI to fix that. There is a ask Copilot to fix, and then you will get a faster fix. That's one of the way to fix it. Okay. Another place where you can do it is what you can do is you can see there is a @local variable. So while running in debug mode, and you have some specific inputs values that are actually causing issues, then you have to know exactly what is the value of the input variable and what is the output variable generated, and what is the difference from the original expected output. So then what you can do is you can actually, while still in debug mode, while still you have a breakpoint set up so that the variables are still retaining those data, you can use an @locals as a annotation to let Copilot access those runtime variables. And once the AI is able to see what is the input, output, etc., and then you ask it to fix the error that you are facing, it can much easily fix that issue. This is one of the enablers that is available in the GitHub Copilot. Okay, and while sometimes it is okay to set the mark points, many times what happens is in a loop, particularly sometimes infinite while loops, you don't want to hit the mark point every time. Then you have to only hit the mark point at certain condition met. Then what is the right condition to set will also be difficult and takes time to set. Then what you can do is even setting the mark point conditions, we can use AI. So Copilot can help us do that. So that way, what happens is it is much more easier to set them there. Okay. And this is what is talking about as deadlocks, where the AI can actually help us to detect, and we can actually ask a Copilot to fix it as well. And it can actually look into the details exactly, and then it gives you suggestions on what are the things that we want to take, and then we choose the option, and it actually fixes it faster. So this is an example of a debugging workflow that we can use for particularly for AI bug fixing. Okay, so since we have very short amount of time now, I'm actually not running them, but we can do that. Okay, so test-driven development again. So at a high level, I'll tell you what I want to say. So basically, there are different tools like we have Cursor, we have GitHub Copilot, etc. So in the case of GitHub Copilot, a lot of times what I observed is if you write a code or you make a code change and you do a refactoring, etc. So there are a lot of things that have changed. New APIs have added. So then what happens is in the development workflow, first you have to write the code. Then you ask the Copilot, okay, so there is a lot of changes done. So these are the changes. Correspondingly, go to the Git, for example, the test code, and then update the test cases. So this is typically what we do in GitHub Copilot. But if you're working with tools like Cursor, then you just give the new requirement, ask it to fix it, like update it. Then in its development workflow, automatically it identifies the new changes, implements all of those code changes in the code workflow, and then automatically it also writes the test cases and finishes it. So which means in the agentic mode of the Cursor, bug fixing and writing test code, all of that is built within the functionality of the code generation workflow itself. So which means when you are building such systems and when you develop the workflows, you also have to consider end to end the complete use case. It's not just about the partial task to be done, but complete workflows. If we can implement, then what happens is completeness, including the test code generation, will become part of the workflow rather than you expect the AI user to generate. Okay, so that's about AI native test-driven development is actually more related to that. Okay, so let the AI do that automatically. That's one of our expectation. Okay, so these are the common tools. The top three are the commonly used ones. Okay, so GitHub Copilot, Cursor, and Claude. And in my knowledge, Cursor is the most powerful tool that we have. The next best is Claude Code also, so where you can actually run it in the CLI mode as well. And GitHub Copilot is also frequently used when I work with the VS Code, etc. Okay, so summary is you can see AI agents do not just execute code, write code. So they can plan, they assess, they execute, and then they also verify, and they help you to completely implement entire workflows, entire code development tasks. And there are multi-agent systems that can do very complex things. I've showed you an example of how I will build agents, but also we can build similar agents and then plug them together to have very complex use cases. Okay, and there are a lot of agentic frameworks that help us to implement them. Like you have seen, Autogen is actually a low-code solution. N8N is another low-code solution. And then Crew AI LangGraph also can ensure that we can implement complete workflows, enterprise workflows in the exact same way we want. And that will always follow the same path that we expect. Okay, so I think I have some slides, but maybe we will take any questions you have. Last 2 minutes is there, so I'll leave it for any questions if you have. Okay, there was a question. So could you elaborate how you can build AI agent skills practically, particularly within a healthcare platform environment without relying on traditional APIs? Effectively incorporate existing workflows, what considerations should we have for token governance, etc. Okay, so first for healthcare, again, so you will have the domain knowledge that you will expect. And then based on that domain knowledge, we have to build the agents, and mostly it will be prompt driven, as I said. And related to token usage, that's a totally different aspect. So basically what happens is in the case of tokens, particularly when you are using agents, so you have different models. So each model has a different token capacity, etc., and cost also. Okay, so from that aspect, we have to consider what are the best models we want from the costing perspective. So in terms of exact token usage, a lot depends on the prompts that we use, because sometimes some prompts will ensure that you directly are trying to solve the problem. Some prompts will be very elaborate. So one of the ways to reduce the token usage is input tokens are also going to be costing you, and that will easily fully fill up the entire context. So there are different types of memory management that you can do where the tokens that are used to consume the context can be reduced. So there is a auto summarizer agent memory that is available. If you can use that, the moment the context is becoming full, it will automatically summarize and only retain the summary rather than taking forward the entire past history. Okay, so that can actually help you to reduce the tokens a little bit. Yeah, I'll check with the Cognixia if they can share it. We'll share that. Yeah. Any other questions? So hope you like the session. I will request you to please fill the feedback form. What I've done is I can see that a couple of feedback was like to make it more practical. So I actually did that in my past experience with you guys. What I identified was even with the AI generating the code fast, it is not fast enough to do that during the session. Then what happened was a lot of time got spent on actually waiting for the AI to finish the code execution, etc. So that's the reason I executed the steps and kept it working so that I can actually directly show you the pre-executed steps. So to save time. So that's what I did. But anyways, I hope the session was useful. Please do leave your feedback before you drop from the call. Thank you.
Thank you so much, Sai sir, for the wonderful webinar. Thank you everyone for your participation. Please note we will share an email with you, which will contain the certificates and a link where you will be able to find the session recordings. There is a feedback link mentioned in the chat. I request all of you to please give your valuable feedback so that we can understand how was your experience regarding this webinar. I'm resharing once again.
Thank you, Deepa. I'll request everyone to please take a moment to fill the feedback. So this is a webinar. Anyways, I couldn't give you the hands-on time, but I try to keep all the exercises pre-generated prior to the session. So, but apart from that, if you would like to share any feedback that really helps, like how you like the session, I'll be glad to know. And I'll be here for another couple of minutes if you need, if you have any questions. Thank you.